There's a reason why I put all these rules here. See, I mean, what, 4 out of 6 of them have a radical on the bottom. And we learned when we talked about trig substitutions that even the ones that don't have radicals on the bottom, we could think of them as having radicals on the bottom, just radical and then square it. So if it has a radical on the bottom, solid chance it's an inverse trig function. Right? So your job is to try to make it look like the rule as much as possible. So that strategy of breaking up the fraction, it's a good strategy, and it's worth investigating. All right? But you're on the hook for a little bit of work. The work is completely related to the first part. Most people find in this unit the U-Substitution topic to be the easier of all the topics that we covered, right? It's to find the U and then go through the process and everything. But then you get to this and you're like, U-Substitution. Because that's the only thing that requires any work in this question. Because this part is a rule. That's arc sine. It's the other part you actually have to do some work for. So you just got to kind of do one of these, a little stretching action, get the shoulders loose, and then just dive right in. Just be mindful of those around you. Because I got long arms, I've taken out more than 1 or 2 people. It was bad when I was a student. I'd be like, all right, oh, okay, that's 2 people, right in the face. Sorry and sorry. So. All right, so we define our u, 1 minus the x squared. Du would be 2x dx. Let's make it a half du equals, negative a half du equals x dx. Now, you could take some liberties here. Instead of writing it as 2 separate integrals, integral of this dx plus integral of that dx, as long as you know that this dx belongs to both, when you go into the next step of the process, you can just jump right to the converted integral. So it would be negative 1/2 du over root u. All right. So then, clean it up, get it in a nicer form. Negative 1/2 u to the negative 1/2 du. Integrate. So u to the 1/2, you're dividing by a 1/2, so negative. Just show me enough work to justify where your answer's coming from, because at this point you could just kind of smush it all together and put your final answer right down on paper and call it a day. Because I know this part here is going to give me negative my u, 1 minus x squared to the 1/2, plus, then I got my rule, which is the inverse sine rule. Go to your note card for that if you need. Arc sine of x plus c. I like writing arc sine. I mean, you've noticed this. A lot of the rules say sine with the -1 power. I like writing the arc sine. The reason I like doing that is because there is absolutely no confusion in terms of where that power is going and what it represents. So, because I have had people plenty of times in the past, they put that -1 in the wrong place. You put it in the wrong place, it means something else. So I'll just write it. This is not the same as this, although it seems like it ought to be, because this is 1 over sine, which is cosecant of x, and this is the arc sine of x. Not the same thing. So just write it as arc sine when you're taking the inverse sine. Question?
This would be number 4. Number 4 would be test.
On the list of strategies?
No,
Oh, that, yeah. Honestly, let me reference myself.
Integration of trig functions.
Oh, no. No, we'll get to that. Trigonometric. I should have this open. Because I just revised the test this morning, cleaned it up, got some of the nonsense out, and then while I was doing it, I put this together. So it wasn't really me being proactive, like I said in my message. It was like, I actually have it right now. I might as well send it out before I forget. Number 4. No. Okay, so integration of trig functions would be something like the antiderivative of secant squared of x, or antiderivative of secant cubed of x. So we'll look at some of those before the night is over.
We're still on basic.
This would be more like number 5, derivative. I'm sorry, not derivatives. Yeah. So this one, I love this problem. Not to say that it's going to be the mystery integral, but it does seem very mysterious, especially when I call it disguised. Like if I didn't give you any guidance on that, I just told you there was going to be a mystery integral, and you're looking through your notes, you see the word disguised, you're like, all right, it's got to be something like this. So I don't, honestly, I don't know if I'm hinting at anything. I might be. I'm probably. Yeah, I'm hinting at something. I just got to remember now that I'm hinting at something. That's my issue, because my mouth writes checks that my typing skills can't. But nobody uses checks anymore, so it's fine. So this is very similar to the last problem on the previous page, although it does not look remotely like it would be. But what it's telling us, based on its title, is that the antiderivative has to involve a log in some capacity. All right, so that gives me a sense, it gives me a thought. It's telling me that the derivative of the bottom of this fraction has to work its way into the top in some capacity, right? Because when you're talking about the antiderivative involving a log, the top is usually the derivative of the bottom. All right, so what is the derivative of the bottom? E to the x. So let me just chuck in an e to the x. I can't just do that. So let me unchuck it in. So put one in, pull one out. So it actually ends up being the exact same strategy. It just looks a lot different. Because I'm going to break this up by that minus sign and write it as 1 plus e to the x over 1 plus e to the x minus e to the x over 1 plus e to the x dx. Now, two like quantities always divide to equal 1. This, we know, is a constant, so its antiderivative should just be the variable minus ln. And then we don't have to do u sub here, although you can if you want. We do a little u sub on the fly, or baby u sub as I like to call it. And that's saying, take a stab at it, consider what it might be, and then just check. Right? So if I took the derivative of this, it would be 1 over this times the derivative of this. The derivative of this is e to the x. So I have exactly what I need. So we are in beautiful shape.